This is a short video on radiation, alpha, beta and gamma radiation, and it explains what happens to the nucleus of the radioisotope and shows you how you can work out the equations. Please don't forget to press like and subscribe. As well as that, there are some further resources available at my shop on the Times Education supplement. Just follow the link below. So alpha radiation, written as an alpha symbol, is the same as a helium nucleus for 2. So a helium nucleus is 4 particles, 2 of which are protons. So the other 2 are neutrons. So it's 2 protons and 2 neutrons. And it's emitted by the nucleus of a radioisotope. In equations, you'll write it as alpha 4-2. It's the most ionizing. And because it's the most ionizing, it's actually the least penetrating. So most ionizing, it will, if it gets inside you, ionize. And this can happen inside your lungs if you happen to breathe in some radon gas. It's the least penetrating because it can't get through even your skin. So if it's outside your body, it's safe. Let's have a look at americium-241. Now, americium-241 is the element that's used in smoke detectors. And americium-241, it's 95 for the proton number, emits an alpha particle. And the alpha particle in the smoke detector will ionize the air because it is so ionizing, and then you end up with positive and negative particles in the air. Those positive and negative particles are attracted to positive and negative plates, which sets up a current. The smoke displaces that current, and because of that, the alarm goes off. Anyway, so what happens to the americium once it's emitted, that alpha particle? Well, it's emitted 2 neutrons from its nucleus and 2 protons from its nucleus. So this number here is the atomic mass. So its atomic mass will go down by 4, so 241. Take away 4 will leave us with 237. Now that number doesn't tell us what the element is. It's only the bottom number that will tell us the element. So what happens to that? Well, americium has 95 protons in it. That's what that 95 there tells us. It's lost 2 protons from the nucleus. So instead of being 95, it'll now be 93. Now we can look up the element that has 93 protons. And the element with 93 protons is NP, neptunium. Let's have a look at beta radiation. So it's written as a B, like so. It's a fast-moving, high-energy electron. The charge on an electron is -1. It's moderately penetrating. It'll get through aluminium. And it's moderately ionizing because it has a charge. It's dangerous outside your body because it can get inside your body through your skin. But it's also dangerous inside your body because it can ionize. But it might get outside your body. Okay, so strontium-90 is an isotope that emits a beta particle. Strontium-90 emits a beta particle. Strontium has 38 protons in its nucleus. It emits a beta -1 particle. Now, the high-energy electron has almost no mass, so hence there's a 0 there. And beta emission occurs when a neutron breaks down into a proton plus this beta particle. So the proton number goes up. The mass number stays the same because a neutron has just changed to a proton. So that remains as 90, but that doesn't help us decide what the element is. The proton number goes up by 1, though, to 39. And when you do that, you get yttrium as the element. Now let's just look carefully at what's happened to these numbers, because that can help you check your equation. Let's go back to the americium one. 4 plus 237 equals 241. 2 plus 93 equals 95. Let's see if the same holds true for the beta decay. 0 plus 90 is 90. Minus 1 plus 39 is indeed 38. So you've got a way of checking whether your equation is correct or not. Gamma radiation. The first two here are both particles. Alpha and beta are particles. Gamma isn't. Gamma is a ray. It's an electromagnetic wave. EM wave. And it's on the electromagnetic spectrum. Quite often it's denoted as gamma like so. And gamma is next to X-rays. And then you get UV. And then you get violet. Richard of York gave battle in vain. Over to red. And then infrared on the electromagnetic spectrum. Microwaves. And then finally you'd get radio further on. Gamma rays and X-rays, they're actually indistinguishable in truth. The only way you'd know is where they came from, and the X-ray comes from a Liniac machine in a hospital. Gamma's coming from the nucleus of a decaying element. Iodine 131 is a gamma ray source. So I hope that's helped you a little bit, and I hope it's given you enough information to have a go at the questions before I go through them. So here are the questions. Pause it now if you want to have a go at them yourself, and in a second or two I will go through them. You'll need either access to a periodic table, or if you've got the internet, that can help you find the elements as well. So I'll get going then. Cesium, CS 131, that's the atomic mass, and the atomic number is 55. And it's undergoing beta decay. So we need to work out what the new element is. 55, that's minus 1 plus something equals 55, so that must be 56. And that's a 0, so that's 131. So the element has 56 protons in it, and it's Ba. Next one is cobalt 60. Cobalt 60 has 27 protons in its nucleus. And again, we're undergoing beta decay. So that's a minus 1, a 0. So 0 plus something equals 60, so it's got to be 60. 27 and minus 1, so that would be now 28. We can look up the 28, and we're going to get Ni for nickel. Next one is polonium 218, and it's alpha decay. So it's 218 PO for polonium, and polonium's 84 protons in the nucleus, and that's going to decay to give an alpha particle 42. So it's lost 2 from 84, which would give 82, and it's lost 4 from 218, which is 214, and the element is Pb, or lead. And lastly, we've got uranium, and it's 234, and 92 protons in the uranium. So what happens to it? Well, it loses 4 things from its nucleus, and it loses 2 protons. So it loses 2 protons, 2 neutrons. So 234 minus 4 is 230, and 92 minus 2 is 90, and that will become thorium. So there we have 2 alpha decays and 2 beta decays. Just having a closer look at these, the beta decays move up the periodic table. So beta up the periodic table because it gains 1 proton. Alpha, on the other hand, goes down the periodic table. Because the nucleus has the loss of 2 protons. Okay, I hope you found this useful. I hope you had a go at the questions. Please don't forget to press subscribe and like. And if you need any more resources, look at the TESS shop. Thank you very much.